Hello mga Acute Angels! Welcome back for another Mathinik episode. This is Teacher Mika
And this is Teacher Joyme.
Today, we will learn about special products.
After going through this module, you are expected to use models and algebraic methods to find the product of two binomials, product of the sum and difference of two terms, square of a binomial, cube of a binomial, and product of a binomial and a trinomial. But before anything else, let's have an activity entitled Paper Folding for the quantity of a plus b raised to 2. The only material that we need in this activity is a piece of square paper. Step 1. Fold the paper to form a vertical crease parallel to the edge. Label the longer dimension letter A and the shorter dimension letter B. Let the intersection of the crease and the edge be point C. Here's the representation of step 1. Step 2. Fold the upper right-hand corner over onto the crease to form a square. Locate point D. Here's the representation of step 2. Step 3. Fold a horizontal crease through D and label all outside dimensions. Here's an example. Step 4. Find the areas of the two squares and two rectangles formed. Let's start with the area of square 1. The dimension of square 1, which is the smaller square, is b times b. Therefore, the area of square 1 is b squared. Next, the area of square 2. The dimensions of square 2, which is the bigger square, is a times a. Therefore, its area is a squared. Third, the area of rectangle A. The dimension of rectangle A is a times b. Therefore, its area is ab. And lastly, the area of rectangle B. The dimension of rectangle B is also a times b. Thus, its area would also be ab. Step 5. What are the dimensions of the original figure? Okay, so by taking the sum of the areas, we can say that the dimension of the original figure is b squared plus a squared plus ab plus ab. Expressing it in standard form and combining like terms, we have a squared plus 2ab plus b squared. And lastly, can you show that the four areas taken together equal to the quantity of a plus b times the quantity of a plus b? How about the quantity of a plus b raised to 2? That's what we're going to talk about in our discussion for today, which is
Special products. Let's start with the product of two binomials. As we have previously discussed, binomial is a polynomial with two terms. For example, 5y cubed minus 3, 2x plus 5, a plus b. And product means the result we get after multiplying. Now, we will multiply binomials using the FOIL method and the vertical method, but these were already discussed in our previous lesson. So let's take a look again. Multiplying two binomials using FOIL method. To find the product of two binomials, we use the distributive property of multiplication over addition. Using this property, we multiply every term of one binomial by every term of the other binomial and then combine like terms. For example, the quantity of x plus 2 times the quantity of x minus y. Multiply the first terms. X times x is x squared. Multiply the outer terms. X times negative y is negative xy. Multiply the inner terms. 2 times x is positive 2x. And lastly, multiply the last terms. which is 2 times negative y is negative 2y. Therefore, the quantity of x plus 2 times the quantity of x minus y is equal to x squared minus xy plus 2x minus 2y. Let's have more examples on product of two binomials. Number 1. The quantity of x plus 3 times the quantity of x plus 2. Using the FOIL method, we multiply the first terms, which is x times x is x squared. Multiply the outer terms, x times 2 is positive 2x. Multiply the inner terms, 3 times x, which is 3x. And multiply the last terms. 3 times 2 is positive 6. Then we combine like terms. 2x plus 3x is equal to 5x. So therefore, our answer is x squared plus 5x plus 6. Example number 2. The quantity of x minus 4 times the quantity of x minus 3. Again, multiply the first terms. X times x is x squared. Then, multiply the outer terms. X times negative 3 is negative 3x. Multiply the inner term, which is negative 4 times x is negative 4x. And multiply the last terms. Negative 4 times negative 3 is positive 12. Now, combine like terms. Negative 3x plus negative 4x is negative 7x. Therefore, x squared minus 7x plus 12 is the product of the two binomials x minus 4 and x minus 3.
Multiplying two binomials using the vertical method. The FOIL method is usually the quickest method for multiplying two binomials, but it works only for binomials. You can use the distributive property to find the product of any two polynomials. Another method that works for all polynomials is the vertical method. It is very much like the method you use to multiply whole numbers. Look carefully at this example of multiplying two-digit numbers. First, you start by multiplying 23 by 6 to get 138. Then, you multiply 23 by 4, lining up the partial product in the correct columns. And last, you add the partial products. Now, we'll apply this same method to multiply two binomials. For example, multiply using the vertical method the quantity of 5x minus 1 times the quantity of 2x minus 7. Note, it does not matter which binomial goes on top. Line up the columns when you multiply as we did when we multiplied 23 by 46. Step 1. Multiply 2x minus 7 by negative 1. That is, negative 2x plus 7 as our partial product. And then, we multiply 2x minus 7 by 5x. So that is 10x squared minus 35x as another partial products. And then combining like terms, we have 10x squared minus 37x plus 7 as our product. Let's have another illustrative examples. Example number 1. Use vertical method to multiply and simplify the quantity of 2x minus 5 times the quantity of 3x plus 4. First, we multiply 2x minus 5 to positive 4. That is 8x minus 20 as our partial product. Next, we multiply also 2x minus 5 to positive 3x. So that is 6x squared minus 15x as another partial product. Combining like terms, we have 6x squared minus 7x minus 20 as our product. Example number 2. Use vertical method to multiply and simplify the quantity of negative 4x minus 1 times the quantity of 5x minus 7. Again, we will just apply the same process, so we will multiply negative 4x minus 1 to negative 7. That gives us 28x plus 7 as our partial product. Next, we also multiply negative 4x minus 1 to positive 5x, and that gives us negative 20x squared minus 5x. Combining like terms, we have negative 20x squared minus 23x plus 7 as our product.
Product of the sum and difference of two terms. How to find the product of sum and difference of two binomials with the same terms and opposite signs. Let's have the quantity of a plus b times the quantity of a minus b. In here, we have same terms, a and b. We have opposite signs, plus and minus. For us to illustrate how to get its product, we will use the FOIL method. Multiply the first terms, a times a is a squared. Multiply the outer terms, a times negative b is negative ab. Multiply the inner terms, b times a is positive ba. And lastly, multiply the last terms, b times negative b is negative b squared. Combining the like terms, negative ab plus ba, we have 0. So therefore we cancel it. So we have now a squared minus b squared. Therefore, the quantity of a plus b times the quantity of a minus b is equal to a squared minus b squared. It is stated that the product of the sum and difference of two binomials with the same terms and opposite signs is equal to the square of the first term minus the square of the second term. Let's have some examples. Number 1. The quantity of 2x plus 7y times the quantity of 2x minus 7y. Remember the technique a while ago. Square the first term minus square the second term. In here, our first term is 2x. So we have 2x squared minus our second term is 7y, so we have 7y squared. Simplifying it, we have 4x squared minus 49y squared. Therefore, the quantity of 2x plus 7y times the quantity of 2x minus 7y is equal to 4x squared minus 49y squared. Example number 2. Find the product of the quantity x plus 3 and the quantity x minus 3. In here, our first term is x and our second term is 3. So to solve, square the first term, which is x squared, minus square the second term, which is 3 squared. Simplifying it, we have x squared minus 9. Therefore, the quantity of x plus 3 times the quantity of x minus 3 is equal to x squared minus 9. For numbers 3, 4, and 5, you will be given 30 seconds to find the product of the given binomials. Your 30 seconds start now. Let's check your answers. Number 3. The quantity of 3y plus 5 times the quantity of 3y minus 5. The answer is 9y squared minus 25. Number 4. The quantity of 2x minus 4y times the quantity of 2x plus 4y. The answer is 4x squared minus 16y squared. And number 5, the quantity of 5a minus 2b times the quantity of 5a plus 2b. And the answer is 25a squared minus 4b squared. Did you get all the answers? Great!
Square of binomials. The square of a binomial is the sum of the square of the first terms, twice the product of the two terms, and the square of the last term. It might sound confusing, so let's take a look at it. For example, we have to get the square of the binomial x plus y. First, we have to square the first term, so that is x squared. And then twice the product of the two terms, so that is positive 2xy. And then square of the last term, that is positive y squared. Therefore, the square of the binomial x plus y is equal to x squared plus 2xy plus y squared. Next, we have to get also the square of the binomial x minus y. So first, we have to square the first term, so that is x squared. And then twice the product of the two terms, so that is negative 2xy. And then square of the last term, so that is positive y squared. Therefore, the square of the binomial x minus y is equal to x squared minus 2xy plus y squared. Remember that the square of a binomial is also called perfect square trinomial. Let's have the illustrative examples. Example number 1. Find the product of the quantity of a plus 3 raised to 2. Following the pattern of the square of binomials, we have to square the first term, so that is a squared, plus twice the product of the first and second term, so that is 2 times a times 3, plus square of the last term, that is 3 squared. Simplifying, we have a squared plus 6a plus 9. Example number 2. Find the product of the quantity of y minus 4 raised to 2. Following the pattern on the square of binomials, we have to square the first term, that is y squared, minus twice the product of the first and second term. So that is minus 2 times y times 4, plus square of the last term, that is 4 squared. Simplifying, we have y squared minus 8y plus 16. For numbers 3, 4, and 5, you will be given 1 minute to find the square of the given binomials. Your 1 minute starts now. Let's check your answers. For number 3, the quantity of 3a plus 5 raised to 2. Squaring the first term, we have the quantity of 3a raised to 2 plus twice the product of the first and second term. That is 2 times 3a times 5 plus square of the last term, that is 5 squared. Simplifying, we have 9a squared plus 30a plus 25. Number 4. The quantity of x minus 7 raised to 2. Squaring the first term, we have x squared minus twice the product of the first and second term. That is minus 2 times x times 7 plus square of the last term, that is 7 squared. Simplifying, we have x squared minus 14x plus 49. Number 5. The quantity of 3c plus 2d raised to 2. Squaring the first term, we have the quantity of 3c raised to 2 plus twice the product of the first and second term. That is 2 times 3c times 2d plus square of the last term, that is the quantity of 2d raised to 2. Simplifying, we have 9c squared plus 12cd plus 4d squared. I hope you get the answers right.
Cube of binomial. For cubing a binomial, we need to know the formulas if we encounter binomial with this case. Let's say we have the cube of binomial a plus b. So what we need to do is, number 1, cube the first term. Number 2, plus 3 times the square of the first term times the second term. Number 3, plus 3 times the first term times the square of the second term. And number 4, plus the cube of the second term. How about if we encounter binomial with this case? Let's say we have the cube of binomial a minus b. So what we need to do is, number 1, cube the first term. Number 2, minus 3 times the square of the first term times the second term. Number 3, plus 3 times the first term times the square of the second term. And number 4, minus the cube of the second term. Let's have some examples. Find the cube of binomial x plus 5y. In here, we will use the case 1, where a is equal to x and b is equal to 5y. First, cube the first term, which is x cubed. Number 2, plus 3 times the square of the first term times the second term. So we have plus 3 times x squared times 5y. Next, plus 3 times the first term times the square of the second term. So we have plus 3 times x times 5y squared. And lastly, plus the cube of the second term. So we have 5y cubed. Simplifying it, we have x cubed plus 3 times 5 is 15, x squared y, plus square root of 5, which is 25, times 3, we have 75x y squared, plus 125y cubed. So therefore, the cube of binomial x plus 5y is equal to x cubed plus 15x squared y plus 75xy squared plus 125y cubed. Example number 2. Cube of binomial 2 minus 3x. In here, we will use the case number 2, where a is equal to 2 and b is equal to 3x. To solve this, cube the first term, we have 2 cubed minus 3 times the square of the first term times the second term, which is minus 3 times 2 squared times 3x, plus 3 times the first term times the square of the second term, which is plus 3 times 2 times 3x squared. And lastly, minus the cube of the second term, which is minus 3x cubed. Simplifying it, we have 2 cubed is 8 minus 2 squared is 4 times 3 times 3x is 36x plus 3x squared is 9x squared times 3 times 2 is equal to 54x squared minus 3x cubed is equal to 27x cubed. So therefore, the cube of binomial 2 minus 3x is equal to 8 minus 36x plus 54x squared minus 27x cubed. For numbers 3, 4, and 5, you will be given 1 minute to find the cube of the given binomials. Your 1 minute starts now. Let's check your answers. For number 3, the cube of binomial x plus 1 is equal to x cubed plus 3x squared plus 3x plus 1. Number 4, the cube of binomial y minus 2 is equal to y cubed minus 6y squared plus 12y minus 8. And for number 5, the cube of binomial 2x plus 3 is equal to 8x cubed plus 36x squared plus 54x plus 27.
Product of binomial and trinomial. These factors have the following characteristics. The first term of the trinomial is the square of the first term of the binomial. Let's take a look at the given on the sum of two cubes. Our binomial is x plus y, and our trinomial is x squared minus xy plus y squared. So the first term of our trinomial is x squared. Is it the square of the first term of the binomial? Yes. So the first characteristic is satisfied. Number 2. The second term of the trinomial is the additive inverse of the product of the first and second term of the binomial. The second term of our trinomial here is negative xy. Is it the additive inverse of the product of xy? Yes. So, the second characteristic is satisfied. Number 3. The third term of the trinomial is the square of the second term of the binomial. The third term of our binomial is y squared. Is it the square of the second term of our binomial? Obviously, yes. Therefore, the third characteristic is also satisfied. Thus, in getting the final answer of the special case of the binomial and trinomial, we just have to get the cube of the first term of our binomial factor, so that is x cubed, plus the cube of the second term of the binomial factor, so that is y cubed. Therefore, the product of the binomial x plus y times the trinomial x squared minus xy plus y squared is just equal to x cubed plus y cubed. The same rule applies on the difference of two cubes. There's just only a little difference on the operations. If the operation on the binomial is minus, then the operation on the trinomial must be all addition. And the product would be x cubed minus y cubed. Note that the final answer should always have two terms. Let's have the illustrative examples. Example number 1. Find the product of the quantity of x minus 1 times the quantity of x squared plus x plus 1. We will check first if the pattern was satisfied. Then, we will apply the identity. So, let's take a look at our trinomial and our binomial. The first term of our trinomial is x squared, which is the square of the first term of our binomial. Next, the second term of our trinomial is positive x, which is the additive inverse of the product of the first and second term of our binomial. And lastly, the third term is positive 1, which is the square of the second term of our binomial. Thus, in getting the final answer, we will just cube the first term of our binomial, which is x cubed, minus the cube of the second term of our binomial, which is 1 cubed. Therefore, the final answer is x cubed minus 1. Example number 2. Find the product of the quantity of x plus 3 times the quantity of x squared minus 3x plus 9. We will check first again the pattern if it was satisfied. Then, we will apply the identity. So first, the first term of our trinomial is x squared, which is the square of the first term of our binomial. And then, the second term of our trinomial is negative 3x, which is the additive inverse of the product of the first and second term of our binomial. And lastly, the third term of our trinomial is positive 9, which is the square of the second term of our binomial. Thus, we will just get the cube of our first term, which is x cubed, plus the cube of the second term of our binomial, which is 3 cubed. Therefore, the final answer is x cubed plus 27. For numbers 3, 4, and 5, you will be given 1 minute to find the product of the given binomials and trinomials. Your 1 minute starts now. Let's check your answers. Number 3, the quantity of 3y minus 2 times the quantity of 9y squared plus 6y plus 4. The pattern was satisfied, so we'll just apply the identity wherein we have to get the cube of the first term, which is the quantity of 3y raised to 3 minus the cube of the second term of our binomial, which is 2 cubed. Simplifying, we have 27y cubed minus 8 as our final answer. Number 4. The quantity of 5x plus 3y times the quantity of 25x squared minus 15xy plus 9y squared. The pattern was satisfied, so we will again apply the identity wherein we have to get the cube of the first term of our binomial, which is the quantity of 5x raised to 3, plus the cube of the second term of our binomial, which is the quantity of 3y raised to 3. Simplifying, we have 125x cubed plus 27y cubed as our final answer. And lastly, number 5, the quantity of 4a minus b times the quantity of 16a squared plus 4ab plus b squared. The pattern was satisfied again, so we will just apply the identity by getting the cube of the first term of our binomial, which is the quantity of 4a raised to 3 minus the cube of the second term of our binomial, which is b cubed. Simplifying, we have 64a cubed minus b cubed as our final answer. I hope you got the answers right.
That ends our lesson today. We hope you learned something. See you on our next episode, Acute Angels. Keep safe!